Welcome back once again, everybody. In today's lesson, we are going to be focusing on zero and negative exponents. Our main objectives are going to be to evaluate and simplify expressions that have those exponents. So we're going to have to learn what having an exponent of zero and what having a negative exponent can actually do to an expression. So we'll go ahead and jump into our first key idea. So with our key ideas, we see first with zero exponents, it says for any non-zero number, a, we'll call it, so the base, a to the power of 0 equals 1, except for 0 to the power of 0. If you get 0 to the power of 0, that is simply undefined. So again, as long as the base isn't 0, it's non-zero. If it's any other number, decimal fraction, whole number, or anything else, anything to the power of 0, except for 0, is 1. I get a lot of questions as to why this is, so what I'm actually going to do is partially borrow um, some ideas from the property lessons we've watched here recently and use a very simplistic line of reasoning. For example, if we had 5 to the first power over 5 to the first power, we'd want to use the quotient of powers property, and the quotient of powers property says to subtract our exponents here. Well, 1 minus 1 is 0, so this would be equal to 5 to the power of 0. Now, how does that help us understand why it's equal to 1? Well, let's actually evaluate these numbers, so I'm going to work backwards for a moment. What is 5 to the first power? Of course, that's 5. And 5 to the first power again is 5. And then we can see that clearly 5 divided by 5 is 1, which helps us prove then that 5 to the power of 0 is in fact 1, or anything to the power of 0 is going to end up in that same circumstance. Now the next one isn't as clearly defined, so we're not going to go as in depth, but we see now for negative exponents that for any integer n and any non-zero number a, so we have a to some negative integer, so some negative whole number, is the reciprocal of a to that power. So this one gets a little bit trickier, and will take you a little bit more focus, but we see here at the beginning we have 4 to the power of negative 2. All that equals then is 1 over 4 to the negative 2. So when they say reciprocal, remember that this right here just represents a value, but we could write that same value as itself over 1. So those two numbers, the 1 and the 4 to the negative 2, because of the negative exponent, they are just going to change position. So we get 1 over 4 squared. But notice here that the negative has gone away once you create that reciprocal. The negative won't carry through. Some of this will become a little bit easier to interact with once we take a look at some examples. So let's just go ahead and do that now. So here in part A, we have 3 to the power of negative 4. So this, of course, would be a negative exponent. And we know that now that once we have a negative exponent, we actually get the reciprocal of a to the positive exponent. So this would be 3 to the negative 4th over 1. We would then flip them to find the reciprocal and get 1 over 3 to the positive 4th power. For part B, notice that we're actually multiplying here, so we do have a product of powers property situation, which means we need to add our exponents together. We would have the same base, negative 8.5, and then we add negative 4 plus positive 4, but of course negative 4 and positive 4 are opposites, meaning their sum is automatically 0, so we get negative 8.5 to the power of 0. So here we're going to be looking at a 0 exponent, and what we learned is that any non-zero number, and negative 8.5 is definitely not 0, to the power of 0, though, that is equivalent to just 1. Right? That's all there is to it. But you're going to have to interact with those on your own, so I have a couple on your own examples for you to try before we continue. Okay, so here are 6 for you to try on your own that mixes some basic ideas with some more complex ones. Go ahead and pause the video, and in about 3 to 5 more seconds, you guys will get some solutions to double check your work. All right, so here you guys go. For number 1, you should have had 1/16 or 1 over 4 squared if you left it as a power. Number 2 would be negative 1/32. Number 3 is just 1. Number 4 should be negative 1/3. Number 5 would be 1 125th, or again, you may have had 1 over 5 to the 3rd power. if you left it as a power. And lastly, number 6 would just be 1. Let me know if you had any questions about those through an email, and otherwise we're going to go on to our next example. And for our last example here, we're just going to simplify some expressions, mixing again some of our more recent properties all together here. While it doesn't have the directions explicitly written out here, listen carefully, because on big ideas or some of your later work, the directions will say simplify, but then they'll also say write the expression using only positive exponents. Of course, that really shows up in part B. We can see pretty clearly there's a negative exponent, and they want you to rewrite it so it doesn't have any negative exponents. So let's see how these ones will work. First, in part A, we're going to need to simplify things by expanding this out a little bit. So first thing is to look at the fact that this has negative 5 times x to the power of 0. And the reason that I'm going to expand that for just a brief moment is because it's important to recognize that it is x being raised to the power of 0, and only x that is being raised to the power of 0, so that we can simplify just that piece. Now remember that anything to the power of 0, including variables, is just going to give us a value of 1. As long as that base isn't 0 itself, anything to the power of 0 is 1, and I can't emphasize that enough. Of course, then we'd have negative 5 times, now something that has a value of 1, and negative 5 times 1 is just negative 5. And there, we've simplified it all we can. Next, I'm going to start off the same way and expand things just a little bit, and I'm going to say 9 times y to the negative 3rd power over y to the 5th power. And again, the reason that I wanted to expand those out is because now I can see that these two factors, the y terms, those are going to interact directly. The 9 doesn't have anything it's going to interact with. I mean, technically there is a coefficient of 1 here, but if I went to simplify 9 divided by 1, that 9 isn't going to change. So when I go to simplify, it'll still be there. Now, if there had been something like a coefficient of 3, folks, I would want to simplify those. Again, it's just not necessary here. But let's see, y to the 3rd over, y to the negative 3rd over or divided by y to the 5th power actually requires us to now use a quotient of powers property, which in essence means that we're going to have to go ahead and subtract those exponents. So we get y to the negative 3rd minus 5. Again, that was our property from one of our previous lessons. Let's see, negative 3 minus 5, that's negative 8. So we have 9y to the negative 8th power. Very good. Except for that one part of the directions that, again, I apologize, you can't see it here, but will be required of you in your work. We're supposed to be rewriting this without negative exponents. So we're going to say, well, how do I rewrite y to the negative 8th power? Well, that would just be the reciprocal, and I'm going to do that over here to the side for a moment. Y to the negative 8th, or y to the negative 8th over 1, could be better rewritten with positive exponents as 1 over y to the positive 8th. So then when I go to simplify that here in my final problem, I would just take 9 times that, which would be 9 over y to the positive 8th. Or in other words, that y to the 8th gets moved to the opposite part of our fraction, if you will. Again, some of this will take some practice, especially when you think about the negatives and how I'm having to mix in product of power properties and quotient of powers properties and things. But you guys will get to it if you stay focused. Of course, though, please reach out to me if you guys have any extra questions that I can help with. But that should be all for this video. For 0 and negative exponents, we were able to evaluate and simplify expressions in a variety of ways using a variety of properties. Again, email me if you have questions. And as always, guys, I will see you next time.